Hello. This is the video for graphing exponential functions without a calculator. Our essential question is, how do we graph an exponential function without a calculator? First thing I need you to do is copy down these properties. These are the properties of the exponential function. F of x is equal some base b to the x power. We're going to call this the parent. Your properties are as follows. First one, the parent function is going to have no x-intercept. It's never going to cross the x-axis. Second one, y-intercept is going to be 0, 1. Third property, horizontal asymptote will be located on the x-axis, or y equals 0. And the fourth property, f of x is going to equal b to the x, will contain the points 0, 1, 1 comma, whatever that b value is, and -1 comma, the reciprocal of b. Let's go ahead and pause, copy down these properties, and we'll continue on with examples. Okay, moving right along to example 1. Now we're basing this off of the standard form of our exponential function y equals a times b to the x minus h plus k. And the first thing we're going to do, we're going to graph y equals 3 times 4/3 to the x minus 2 plus 1 without a calculator. And the first thing we're going to do is fill in our a, b, h, and k by looking at our equation. Our a value is the number that's being multiplied in front, our coefficient. So our a is going to be 3. Our b is the base that's being raised to the power, so our b is 4/3. H is the number that is being added to the x, or subtracted from the x in the exponent. So our x, and you always do the opposite of the sign, so our h is 2, and k is the number being added at the end. Our k is positive 1. Now that we have those filled in, we're going to come over here and start filling in a chart. Now, over here on the side, I put a little note. You need to start by building a table using the parent, which is just y equals 4/3 to the x. So we want to get rid of the a value, the h value, and the k value. Deal with the parent. So our base number that we are raising to the x power is 4/3. That's going to be our b number. And we're going to always use, as we noted in the properties above, we're always going to use 0, 1, 1 comma b. Well, b is 4/3, so we're going to plug in a 4/3 right here as our second point, 1 comma 4/3, and then the reciprocal of b, which the reciprocal of 4/3 is 3/4. So that's going to be our third point, -1 comma 3/4. You always use these 3 points for your parent function. Now again, what's going to change is what the b number, or the base number being raised to the power, is. Now once I've got those, now I'm going to go over to my horizontal shift. We're going to do our transformations. To do the horizontal shift, you're going to add h, which was 2, to our x value to get our new x. And this will move it sideways, right or left. So our original x was 0. We're going to add 2 to that, and we get a new value of 2. This will be our new x. Our second x value was 1. We add 2 to that. We get a new x value of 3. Our third x value is -1. We're going to add 2 to that, and we're going to get positive 1. Now let's fill in our vertical shift part of our table. You're going to find the vertical shift by multiplying the y value by a, which is 3, and then adding k, which is 1. This will give us our new y. So our y values are 1, 4/3, and 3/4. So we're going to take 1, 4/3, and 3/4, and we're going to multiply each one of those by 3 and add 1 to get a new value. So 1 times 3 plus 1, that's 3 plus 1 is 4. That's our new y. The second one, 4/3 times 3 plus 1. 4/3 times 3 is 4, plus 1 is 5. And our third one, 3/4 times 3, we're going to get a fraction on this one, plus 1. 3 times 3/4 is 9/4, plus 1 is 13/4, or 3.25. So let's write our ordered pairs over here so we can now go plot them. My first ordered pair is 2, 4. My second ordered pair is 3, 5. And my third ordered pair is 1, 3.25. Now using those points along with our horizontal asymptote, our horizontal asymptote is always going to be located at y equals k. Our k was 1, so we're going to have a horizontal asymptote at y equals 1. By using those 3 points and our horizontal asymptote, we should be able to get a pretty close sketch of what this graph will look like. So the first thing I'm going to do is plot my horizontal asymptote, and then I'm going to take these points and I'm going to plot them. And that's what this says, plot your new points and sketch your graph. And we should have a pretty good sketch of what the graph looks like. So 2, 4, go over 2, up 4, and we have our next point. 3, 5, over 3, up 5. And when we plot the third one, 1, 3.25, over 1, and up 3 1/4. And you can see how this is slightly curving. If you were to come up with more points, you could see that they would fit along that line, and eventually it's going to get really close to our horizontal asymptote of y equals 1. Go ahead and pause and finish copying down this example, and then we will finish up with the second and final example. Okay, example 2. This time we want to graph y equals negative 3 to the x, take away 1. So the first thing we're going to do is fill in our a, b, h, and k. Our a is going to be negative 1, because all that's being raised to the x power is 3. So negative 1 is our a. 3 is our b. Notice there is no h number up here with the x, so h is 0. And our k is negative 1. Now that I have that, let's go ahead and fill in our horizontal asymptote. Remember, horizontal asymptote is y equals k. So our horizontal asymptote will be y equals negative 1 this time. And now let's use our information to start filling in our chart. We're going to start with the parent. Our base number, b, was 3, so we're going to be filling in using the parent 3 to the x. And you always start with these points, 0, 1, 1, comma, b. Well, our b this time is 3, so 1, comma, 3. And then negative 1, comma, 1 over b. So 1 over b would be 1/3. The reciprocal of 3 is 1/3. Now that I've done that, we're going to do our horizontal shift. We're going to add h to each x, and you'll notice since h is 0, nothing's going to happen. It's going to stay in the same place, so there is no horizontal shift. So 0 plus 0 is 0. 1 plus 0 is not 0, it's 1. Negative 1 plus 0 is negative 1. So in all of these, our original x changed not at all because our h was 0. So these are our new x's. They didn't change. Now let's do our vertical shift. Our vertical shift, we're multiplying y by a. So our a is negative 1, and then we're adding k, which is also negative 1, to that product. So our Old y was 1. We're going to multiply that by -1, and we're going to add -1 to that product. -1 times 1 is -1, plus a -1 equals -2. Next one, 3 times -1 is -3, plus -1 is -4. Third one, 1/3 times -1 is -1/3, plus -1 is -4/3. So now we have our new x, we have our new y. Let's make our new points. Ordered pairs, 0, -2, 1, -4, -1, -4/3. Pause, finish copying down this information, and then we will finish plotting our points. Okay, so we're ready to plot our points and graph our horizontal asymptote. Our horizontal asymptote is at y equals -1. So let's go ahead and plot that. Now let's plot our point 0, -2. 0, -2 is right here on the y-axis. 1, -4 over 1, down 4, 1, 2, 3, 4. And our third point, -1, -4/3 over -1, down -4/3. You'll notice that this one is very quickly getting close to our horizontal asymptote, and it's going to level off very quickly. Notice that this graph is flipped upside down. Remember how a was equal to -1? Remember, anytime that a is equal to -1, it causes a reflection over the x-axis. So it makes sense that this one would be flipped upside down. Okay, go ahead and pause, finish copying your notes, and we will see you in class tomorrow. Have a good evening.